Hello, Year 12. Here is circles. Screen share on. Let's go. So, of these questions here, hopefully we'll recognise the first one. It would just be kind of 2-3 marks in an exam. This is a pretty standard thing. Written in this form, that equation isn't particularly useful. So what we should do instead is, well, firstly, I'm just changing the order. I'll put that 15 on the right-hand side as well. What we're aiming for is equation of the form x minus a squared plus y minus b squared is equal to r squared. And that, of course, is the standard equation for this for a circle with a centre at AB and a radius of r. So I'm aiming to write my red equation in that form there, and we do it by 2 mini completing the squares. Now, earlier, back in September, you'd have done some quite complicated completing the squares. Here, however, with circles, it's just fairly basic ones. So we halve that coefficient there, which is where the 3 comes from, but then we need to subtract that 3 squared. Same for the y's. So there I've got a coefficient of 2. So I halve that. I said a coefficient of 2, of course, I meant minus 2. And then I need to subtract the 1 squared because that's extra. That's equal to 15. So x plus 3 squared plus y minus 1 squared. I have a 9 and a 1, so 15 and 9 and 1. If I pop that on the right, x plus 3 squared and y minus 1 squared is equal to 25. So that means that the centre of my circle is at negative 3, 1. And the radius, so all we need to do is remember to square root that 25. So the radius is equal to 5. Okay, so next up, we need to do a little bit more. We've got to find the equation of a tangent. Now, immediately you see that word tangent, you probably think dy dx, you think gradients. However, for circles, there is one particular thing, one particular property that's special for circles. And that is if I draw a tangent to a circle, this is of course something, circle properties, circle theorems. So I think year 10, probably. Whenever you have got a tangent and a radius, a tangent and a radius are always perpendicular. So essentially the radius is normal to the tangent. You will generally be able to work out the gradient of the radius, because given any circle, you can find its centre. Here, of course, we're given the specific points, so you can find the gradient of the radius, and then we can go on. Use the negative reciprocal to find the gradient of the tangent. So it doesn't ask us to find the centre and the radius. However, you know, that's a pretty standard thing for any circle question. It also just gives you kind of an idea of what it is doing, where it's going. So I've got x squared plus 10x plus y squared minus 6y plus 9 is 0. So I want to halve the x coefficient, subtract the 5 squared, half the y coefficient, subtract 3 squared. Put the 9 on the other side. So I end up with x plus 5 squared plus y minus 3 squared. This 9 and this 9 cancel, so all I've got on the right hand side is the 25. So I know that the centre is negative 5, 3. And the radius is equal to 5. So it doesn't ask me to sketch it, but I always would. Negative 5, 3. So let's, going to need a bit more space there, aren't I? So negative 5, 3. To make sure I've got enough space to draw it all on. Right, I'll stick with that. Negative 5, 3. And because the radius is 5, it's going to end up being there, isn't it? So, oh. Where's my question? Here. So I want to draw this circle here. Whoops. Okay, we'll stop there. So that's negative 5, 3. And that's the radius there, which is 5. The point, negative 2, 7 lies on C. So negative 2, 7 is there. Okay, now my not particularly great circle now might make this a little bit tricky. So what shall we do? If I rub that out, I bet it all goes. Yes, there we go. Let's try and make a bit more of an effort. So around there. Okay, something very horrible goes for the bottom bit of the circle, but that doesn't matter for what we need. Right, so I'm now going to draw in my tangent. So my tangent is going here. I can't work out the gradient of that immediately, but I can work out the gradient of my radius. I know that the point P has coordinates negative 2 and 7. So the gradient of the radius then. So if I think of it as y2 minus 1 over x1 minus x1. So that is a gradient equation. Alternatively, you can just, I mean, here's the triangle. I can just see that that length goes from 3 up to 7. So that's going to be 4. And then I know that along it goes from minus 5 to minus 2. So that's going to be 3. Or just use the equation here. So if I do 7 take away 3 over minus 2 take away minus 5. Yeah, I get the same, don't I? I get 4 over 3. So the gradient of the radius is 4/3. So crucial fact then, the gradient of the tangent is perpendicular to the gradient of the radius. So therefore the gradient of my tangent, negative reciprocal, negative 3/4. And then we are using y minus y1 is equal to mx minus x1. With my point P, of course. So I've got that m is negative 3/4, x1 is negative 2, and y1 is 7. Okay, I'm using those because those are my coordinates of P. So y minus y1, which is 7, is equal to m, which is negative 3/4, x minus x1, x take away negative 2. It wants me to write it in the form, in a form with no fractions, everything on one side. So I'm going to multiply both sides by 4. Oh dear. Oh, this is annoying. Let's hope it's still there. So I was about to multiply both sides by 4. 4y minus 28 is equal to negative 3x plus 2. So 4y minus 28 is equal to negative 3x minus 6. Put everything onto the left. 3x plus 4y, and then I've got minus 28, and I'm adding on 6. I think that is minus 22. Okay, so that looks fine. Hopefully no daft mistakes happening anywhere there. Okay, onwards then. 2 more for this section. The points A and B have coordinates. Okay, why not do a sketch? 4, negative 2. So 4, negative 2 is down there. That is A. And 10, 6. So 10, 6 is going to be somewhere up here. That is B. Find the equation of the circle that has got AB as the diameter. Okay, so we're drawing the line AB. I'm now going to attempt to draw a bad circle with that as a diameter. And you know what? That's not bad at all, is it? Okay, from certain angles, that isn't bad at all. We know the equation of a circle if we can find the centre and if we can find the radius. And of course, from those 2 points A and B, we can't find the centre. We are looking at the midpoint. So the centre of the circle is just equal to the midpoints of AB. And the midpoint of AB, if I add the 2 x coordinates, 4 plus 10 over 2, add together the 2 y coordinates, negative 2 plus 6 over 2, that gets me 14 over 2, 7, and 4 over 2, which is 2. That slightly bizarre thing there. To find the radius, well, I can find the length of AB. If I can find the length of AB and then halve that, that of course is going to get me my radius. So the length of AB, we are essentially using Pythagoras, aren't we? So if I draw that there, I have got the length there goes from 4 to 10, so 6 squared. The length there goes from negative 2 up to 6, so 8 squared. 36 and 64 is 100. And the square root of 100 is equal to 10. So the length all the way across is 10. That means that the radius is equal to 5. And so we have now got our equation of a circle. So hence, equation of the circle, the centre is at 7, 2. So that's going to get me to x minus 7 squared plus y minus 2 squared. And that's equal to the radius squared, which is 5 squared, which is my 25. Okay, right, so now I am looking for the equation of the tangent to the circle at point A. Oh, okay, well, this is just, you know, the old standard stuff again, isn't it? So there's nothing particularly tricky there. We're finding the equation of that line there. So shall I call this B? If I work out, why does it keep sticking? Sorry, skipping, not sticking. I want to find the gradient of the radius. The gradient of the radius is just the same as the gradient of the diameter. And I know that that length there is 8. I know that that length there is 6 from my Pythagoras there. So I can just say that the gradient of the radius is 8/6, which is equal to 4/3. So that then tells me that the gradient of the tangent is equal to -3/4. And I now use x1, y1 as the point A. So I'm finding the gradient. Sorry, I'm finding the equation of the tangent at A. So using y minus y1 is equal to x minus x1. I get that y minus y1, which is -2, is equal to m, which is -3/4 x minus x1, which is 4. Multiply 3 by 4, I'm going to have 4y plus 8, because of course I've got a double negative there. It's -3x minus 4, expanding the brackets. 4y plus 8 is -3x plus 12. This time it wants it in the form ax plus by is c. So 3x on the left, the 4y on the left, but on the right it's going to be 12 take away x. Sorry, 12 take away 8, which is 4. Okay, now the last question. We have got to so we're looking at this circle here. Thankfully, I don't have to draw my own circle. Write down an equation, because it says write down, that's implying it really is very straightforward. So that first bit we shouldn't have too much to worry about. But then the point Q has coordinates 10, 0, which is there. A tangent from Q meets a circle at T. Okay, there maybe. Find the length of QT. So that second part is a little bit more complicated. But let's deal with this equation first. I've got 0.9 here. Yep, so that's 0.9. That centre, now because I know it's got a radius of 5, that is telling me where the centre of the circle is. It's got a radius of 5. Because it's touching there, then that is a tangent. So of course this has to be on the same horizontal level there. So if that's a tangent, then that must be the radius. So this is the centre. The y value of the centre then has to be 9. And because the radius is 5, the x coordinate has got to be 9. So I know that the equation of the circle is going to be x minus 5 squared plus y minus 9 squared. The radius is 5, so it's equal to 5 squared, which is equal to 25. Okay, now this next part, slightly interesting, the wording. So it says, okay, we've got this point over here, which is 10,1, maybe there. This is Q, which is 10,1. It says a tangent. Now, why does it say a tangent? Of course, what we can draw there, we can draw a tangent going from there to there, cutting that point there. I say cutting, so I mean just touching. But actually, we've got another tangent up here, haven't we? Haven't made that look quite as tangenty, but we could pretend that's crossing there. If you remember your circle theorems, that length there is actually the same as that length there. So it doesn't matter which tangent you choose, both of them would get you exactly the same length. So whether you take that to be T up there or that to be T down there, they're both going to be the same. I'm not sure which to take. I think I'm liking the bottom one because then it's not going to crash into the 9 in quite the same way. So I'm going to put cube up there. I'm going to draw my tangent. So it just touches there. And that is my point Q. No, that isn't my point Q, that's my point T. And we need to find that length. So it's a little bit awkward, but we just need to carefully think about the properties that we have here. I know that a tangent and the radius are at right angles, so that might be useful. I'm going to mark that in. Okay, and now I can see what to do, I think, because if I could find this length here, if I could find that length there, then what it would mean is that I could use Pythagoras. And in particular, this length, which I'll just go over it again, not particularly well, but this length here, you see it would be the hypotenuse of that triangle there. So if I call this length O, sorry, that length O, if I call the centre of the circle O, then I can see that the angle between the radius and the tangent line QT is 90 degrees. So hence we have a right angled triangle. And we've got a right angled triangle. We know the length OT rather. We know, and I'll just draw that out again, I think. So that length there is 5 because it's the radius. I've got T and I've got O, the centre of the circle, and I've got my point Q. So if we can find this length, I can then use Pythagoras and work out the length of QT. And we can find that length, can't we? Because now that I've drawn that diagram, let's get rid of a few lines here. I know where the centre of the circle is. The centre of the circle is at 5, 9. 5, 9. So if I draw a different right angle triangle, so this right angle triangle, this purple one, isn't the same as this one I've got in blue down here. But I can find this because I know that the length from there to there goes from, I've written, look, 5, 9, I mean negative 5, 9. Oh, so that centre of the circle, apologies, should be plus 5. So I've got negative 5, 9 there. So I'm going from negative 5 to plus 10. So that makes that length 15. And then in the y direction, I'm going from 1 to 9. So that's going to make that 8. So I could say that the length OQ is equal to 8 squared plus 15 squared square rooted. And I'm pretty sure that's a Pythagorean triple, isn't it? 64 plus 225, yeah, 289. If I square root that, I get 17. So I know that this is 17. So hence my length QT, I'm using Pythagoras again, but this time 17 is the hypotenuse. 17 squared minus 5 squared. That's the square root of 264. Which is 2 root 66. Okay, so hopefully no mistakes there. I'm just looking back. Okay, I am just looking at, because I've got an answer in front of me, an answer that somebody else has done, and they got root 22. So what have I done wrong? I'm not sure. I am just going to sign off. So assume that something's right. And if I produce a little correction video, then we know that I have gone wrong somewhere. Okay, apologies if that's the case. Bye for now. See you for logs and exponentials.